Hey, welcome. So today we're going to tackle one of the biggest questions out there. How does the internet actually connect, well, everything? We're going to do this by thinking about it with a simple idea. Imagine every computer network, your home Wi-Fi, your office network, is its own little isolated island. How in the world do you build bridges between them to create one giant connected continent? Let's dig in and see how the architects of the internet solved this massive puzzle.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
Okay, so to really get this, we've got to start small. Before we can even think about building bridges to other islands, we need to understand the rules on our own island. So picture this. All your devices are trapped in a single room. It's its own little digital world, and it can't talk to anything outside its four walls. Now, talking inside this room, that's the easy part. It's kind of like shouting to your friends. It's fast, it's direct, and everyone who's supposed to hear you does. This is what we call local communication, or layer 2. But what if you need to get a message to someone in a completely different room, maybe halfway across the planet? You can't just shout, right? You need a totally different system. You need something like a postal service for the digital world. And that is the challenge. Yeah, that shouting across the room is possible because of what we call layer 2 technologies. Think of the Ethernet cable plugged into your computer. These things are fantastic for local chats on your Wi-Fi or in an office, but their reach is totally limited to that one network, that one island. And that limitation right there brings us to our real mission. How do we send a message across these huge digital oceans that separate all of our network islands? How do we break out of that local room and plug into the entire world? This is the fundamental problem the internet was born to solve. And the solution, you could even say the hero of our story today, is the network layer. You'll also hear it called layer 3. Its whole reason for being is to solve this exact problem, to build those bridges that connect all these independent networks into one single functioning whole. To connect globally, it turns out we need a whole new kind of address. See, a layer 2 MAC address is like your name. It tells everyone who you are, but it gives them no clue where you are. An IP address, on the other hand, that's layer 3, is like your home mailing address. It gives a specific location on the global map. It tells the system not just who you are, but exactly where to deliver the mail. So how does the network layer actually go about building all these bridges? Well, it's not magic. It's actually this really ingenious blueprint. A master plan for connecting the globe that uses 4 essential tools, all working together in harmony. And here's our roadmap for how we're going to understand that blueprint. First up, we need a common language. That's our IP addressing. Second, we need a city plan to keep everything organized. We call that subnetting. Third, we need a translator, which uses a cool process called encapsulation to make the global plan work on a local level. And finally, you need a GPS to find the best way to get from A to B, and that's routing. All right, we've got the blueprint. Now let's zoom in and take a closer look at each of these 4 incredible tools. Because really, understanding how they work is the key to understanding the internet itself. So our first tool is the absolute foundation of everything, IP addressing. This is the universal language. You know, just like a global postal service needs every single house to have a unique address, the internet needs every single connected device to have its own unique IP address. It's what makes your phone or your computer findable among literally billions of other devices. Okay, on to our second tool. Our source material gives this one a little warning label, and for good reason. It can seem a little intimidating at first, but trust me, the idea behind it is actually super intuitive once you look past the math. This tool is called subnetting, and honestly, the best way to think of it is like zip codes for the internet. A mail carrier doesn't need to know the location of every single house in the entire country, right? They just need to get the letter to the right zip code, and the local post office handles it from there. Subnetting does the exact same thing. It uses that binary math to group IP addresses into neat little neighborhoods, and that makes the whole delivery process way more efficient. All right, tool number 3 is our translator. So we've got this global IP address system for the whole world and our local MAC address system for just our room. How do they actually work together? Well, through a clever process called encapsulation. And the analogy here is perfect. It's literally like putting an envelope inside another envelope. So let's walk through it. First, you've got your message, your data. That gets put into what's called a packet. That's the big global envelope, and it's addressed with a final IP address. But to get to the very next step on its journey, that entire packet is put inside another local envelope called a frame. This frame is addressed to the very next device in the chain. When it gets there, that outer envelope gets ripped off, a new one is put on for the next stop, and the whole process just repeats itself, hop by hop. And that brings us to our final and maybe coolest tool, routing. If IP addresses are the destinations, then routing is the internet's GPS. Special devices called routers are constantly talking to each other, using a shared set of rules to map out all the internet's highways and backroads. They work together to figure out the fastest, most efficient path for your packet to travel. What's amazing is that no single router knows the whole map. They just know their neighbors and trust them to pass the message along. It's a global system built entirely on local cooperation. And just like that, with those 4 tools, IP addressing, subnetting, encapsulation, and routing, all working together, the bridges get built. Our islands, which were once totally isolated, are now connected, forming this massive, sprawling world we call the internet. You know, this quote from our source material just says it all, doesn't it? The inter in internet is all about interconnected networks. And without this layer, that connection just flat out doesn't exist. It is the absolute heart of global communication. So if you remember one thing from all this, let it be this. The network layer is the master architect. It gives us the universal language, the city plan, the translation service, and the GPS that all work together to transform a bunch of separate, lonely islands into the single global web we use every single day. But this entire system, this amazing global GPS, is all built on a foundation of rules and cooperation. It's all based on trust. Which makes you wonder, what happens if one of those routers, somewhere along the path, decides to break the rules? What if it decides to lie and tells your data to take a wrong turn? It's something to think about. Thanks for tuning in.